What's up, guys? Welcome to Module 5 of the Intro to Python series. This section is going to be covering code structure. This lesson specifically is just going to be an introduction to the module section of code structure. So what this lesson is going to cover is what is code structure, why does it matter, some principles you should try to keep in mind for writing good code structure, the different layers of code structure. And I'm going to give you an analogy to help you guys kind of understand code structure a little better, some common mistakes, and then we're going to end off with some practice again. So, what is code structure? Code structure refers to how your code is organized and written, including the layout of functions, variables, and classes, the use of modules and files to separate your program's logic, the implementation of clean, consistent formatting, and keep in mind that properly structured code is easier to read, understand, and maintain. So it's really important. So why does it matter? 1. Going into this, readability. Well-structured code is written like a well-written book. It's easy to follow. Clear code helps other developers and future you, when you come back to projects and you're working on large ones, understand what your intentions are behind what you're doing. The next reason is maintainability. Good structure simplifies bug fixes and feature updates. Changes to one part of code should not break unrelated parts. If you don't structure your code right, what could happen is you could update a change in the future that breaks something completely unrelated to it. Imagine a large program where functions are scattered randomly with no clear organization. It makes debugging infinitely harder. The next reason is scalability. A well-structured program is able to grow gracefully whenever complexity or new things are added to it, and it's able to scale in a good way. Modular design allows new features to be added without rewriting everything. The next reason is collaboration. In team projects, structured code ensures everyone can understand and contribute easily to the project, and it just makes everything a lot better. So, here's some principles. Number 1, follow the DRY principle. What DRY stands for is do not repeat yourself. Avoid duplicate code by putting common logic into functions or modules. So here's an example. Print, welcome Alice, welcome Bob, welcome Charlie. Instead of doing this, it's a lot better to have a function, which we're going to go over functions in one of the next lessons in order to do it. So here's an example where greet, and you take in a name, and you print out welcome name. And this makes it so instead of having to write out all this code over and over again, you have it once here, and you call it again. And if you ever want to change all these messages, you can just change them here in one place. The next thing is use descriptive names, which I've stressed multiple times throughout this course. Choosing meaningful names for variables, functions, and classes makes their purpose clear. So here's an example. Here's some poorly named variables, X, Y, Z. As you can see, you just have no idea what's going on here. Here's some more descriptive names. Number of apples, number of oranges, total fruits. Here you have no idea if this is apples or if this is like people's age, people's pay, etc. The next principle is to group related code together. And you can do this using functions, classes, and modules, which we'll cover in this module. So here's an example without grouping. Print area of rectangle, 5 times 10. Print area of circle, 3.4 times whatever. You're just printing out things. Here's grouping things in functions. So here's an example of calculate rectangle area, where you have the functionality into this, and then you're just printing that out. Here's an example with the circle one, and this just makes everything a lot better. Follow consistent formatting is next. Adhere to consistent spacing, indentation, and line breaks for readability. Use style guide like PEP 8, which is standard, and there's tools for that and everything that I'll go over as well. So here's an example of poor formatting. Def add a comma b, return a plus b, where there's just no spaces. It's kind of harder to understand. And here is good formatting of how things should be formatted with the correct amount of spaces between stuff, breaks here, etc. The next principle is to avoid hard-coding things. Replace hard-coded values with variables or constants to make your code flexible. So here's an example where you have price, discount, and final price. Instead of manually subtracting things here, the 100 minus 20, and then printing out for the final price, because then if you have to change stuff, you have to change all these. Just use the variables. It makes things a lot easier if you ever need to change things, expand on things, and it just is a lot easier to understand. So a lot of these principles kind of go hand in hand with each other, but by following them, you'll really be able to make your code really good and separate yourself from other developers. So here's the layers of code structure. The first one is inline code, which are quick experiments or scripts written directly in a file. The next one is functions, which are reusable blocks of code to perform specific tasks. Next is modules and files, which are separate files to organize related functionality. And then last is packages, on top of everything else, which is a collection of related modules often used in larger projects. And you can think of this like a house. So inline code is like if you have just a bunch of tools scattered everywhere. Functions are specific tools placed in a toolbox. Modules are toolboxes grouped by purpose, like on a shelf. And packages are a full toolkit for building houses or building something else ready for use. And proper structure ensures you can find the right tools when you need them, and that you aren't repeating yourself and that you're building things in a correct way. Some common mistakes that people make are overcomplicating structure, and that's the main one. Avoid creating unnecessary layers for small projects. You should create the most simple and usable version of the code for whatever you're trying to make. Right, so here, actually, these should all be common mistakes, my bad. So overcomplicating structure, mixing logic and output, keep your core logic separate from user interface code, and ignoring consistency. Use consistent naming, formatting, and indentation. So now we have some practice problems. Go through them like always and post about them in the community. Pause the video here because I'm going to go through them. The first one is refactor poorly structured code. Also, if you don't understand these yet, they'll be covered in the next few modules. So you can wait to go through those if you want. But I'm going to get started on this first one. Refactor the code. Refactor it to use functions for calculating the area and perimeter. So, get area rectangle. Oops, I forgot to define it. Length, width, and then return length times width. Def get perimeter rectangle, which is length, width, return 2 times length plus width, and print f. And this is really good because if you ever need to get the area of a rectangle again in your program, you could just call this function again instead of having to manually hard code it and write it out like this each time. Get area rectangle. I'm actually going to test if something works because I haven't tried this before. That should work though. Print get perimeter rectangle 510 equals. I forgot to put a space after this one. Oh, I just misspelled it. Get perimeter rectangle. There we go. Okay, task 2. Organize a small program. Create a program that takes 2 numbers as input, performs addition, subtraction, multiplication, and division, prints the result. Okay, so def perform addition, num1, num2, def perform subtraction, num1 minus num2, def perform. I'm misspelling perform every time here. My bad. Perform multiplication. Num1, num2, return num1 times num2, def perform division, num1, num2, return num1, num2. And then I'm going to go def main. Or no, I'll just do it in here. Takes two numbers, performs, prints the results. X comma y equals input. Please enter two numbers, comma y. Separated by a space. Dot split. So I could split their two numbers into the variables. And then print f. Just gonna do a multi-line one here for simplicity's sake. Perform addition with x comma y equals perform subtraction equals perform multiplication perform division five and 6. Okay, I forgot to convert these to an integer. Which I'll have to do like this, I guess. There we go. And as you can see, everything's separated out nice. So if I need to call these ever again or change them, I can. If I want to like add 10 to perform addition for some reason, I can. So that's it for this lesson. I hope you guys learned some things. Yeah, can't wait to see what you guys think in the community. See you guys again in the next lesson.